9.6 is piecewise functions. And this is kind of a little bit different. We're kind of shifting gears a little bit. These last 3 lessons are a little bit, I wouldn't say standalone because they're about functions, but they don't necessarily connect as directly as the last couple lessons with the operations and the compositions and stuff like that. Also, before I forget, I will get your quizzes graded in the grade book like as soon as I can. But on Wednesday, we have the day that we go over your practice test. That's when I'll hand back the quiz because then we'll be able to go over a couple things and talk about a couple different things. Anyways, just want to say that before I forgot. Anyways, piecewise functions are literally just functions in what we did with lines, with slope-intercept form, plugging numbers in. The only difference is now it's a little bit more confusing because they're telling you specifically where to draw each line. So rather than having one line that goes across your whole graph, you will have, well, this one, 2x plus 1, but you only do that one if your x's are bigger than 3. If it's not, then we do this 3. So there's kind of a lot going on here. I don't think today's just like the worst thing ever. There's just a lot going on. So the way you do this, in my what I would recommend, is before I do anything, I like to see where things start and where they stop. Now, a lot of times that will be the same number where they start and stop. It does not have to be, but I like to say, okay, so over here 3. That's kind of the break. I'm going to have one line before that, and I'm going to have one line after that. You do not have to take the time to do that dotted line or to do a light line or anything like that, but I do think that really helps kind of get that mental space where now I definitely know this first one, everything bigger than 3, and the next one is everything less than 3. Let's actually start with the second one, everything is less than 3. That's usually how that is. That's okay. So this one, I know a lot of people forget this, or I guess I should say this. They're just 2 linear functions. So I'm saying f of x is equal to both of those. So that's the same thing as saying y is equal to 3. Again, we're only doing that then if x is less than 3. So make sure you remember these. If you have y is equal to 3, that is a horizontal line. The good news in this chapter, you won't deal with vertical lines. Or in this lesson, we don't have vertical lines. So if you'd have y is equal to a number, or if you just have a number without an x, that's a horizontal line. And the reason I'm stressing that a lot is because you will definitely have a couple of those on the test, because I try to put those on there to make your life easier. Because all you have to do, this is at 3, so that's my y is equal to 3. We have this solid line at y is equal to 3. It goes like that. Where x is less than 3. Now, notice how this one, the second one, doesn't have that line under it, doesn't have the equal to part. That means you start with an open circle. Right there at 3, at x is equal to 3, should have changed that. Right there, at x is equal to 3, open circle. The next one's a little bit confusing because we start at my slope-intercept is 1, but be careful because when you graph this one, you don't graph anything until you get to that 3. So my y-intercept would be 1, and then I go up 2 over 1, up 2 over 1, up 2 over 1, and that's where you would start that graph. I apologize, this was a little bit off your graph. Then that one is filled in. So again, it's a little bit confusing because it's just different, but really the most towards graphing lines, you just have to make sure you remember the hard part is the slope-intercept form, the second one we did. I guess I should say. A lot of people think that since the y-intercept is 1, they start over here at 1, but that is not the y-intercept. So again, you have to imagine you're starting, and I had students do before, where they just draw the whole line and then they just erase the part that they don't need. If you want to do that, that's fine. But that's the biggest thing, and that's how these graphs are going to look. So every one of them has that spot where they start or stop. And then again, you have to see if the circle on there is filled in or open. That depends on this. And then again, you just graph each line according to where it's at. So this is 3 less than 3 on the left. This was the line, everything on the right. So I know it's confusing. Hopefully it gets a little bit better as we go. This second one, the point where everything kind of starts and stops is at 0. So luckily this one is right on your axis, which is kind of nice. So if x is bigger than 0, so we graph this line. If it's to the right, we graph this line when we go to the left. And again, when I say right and left, it's because x is bigger than 0, that's everything to the right. If x is smaller than 0, that's everything to the left. Notice there's no equal signs, so both of these are going to have open circles. So for instance, let's do that red one first. So -2 is the y-intercept. I'm going to leave an open circle there. And then the slope is down 2 over 3 to the right. So down 1, 2 over 1, 2, 3. 1, 2 over 1, 2, 3. And that is our line. Then the other one, again, it's the same. It's just now on the left. So the y-intercept is +3. It's again an open circle. And then it is that to the left. Everything x is less than 0. So normally I'd go up 4 over 3 to the right. But again, that's on this side where we're not graphing that. So I'm going to go down 4, 1, 2, 3, 4, over 1, 2, 3 to the left. 1, 2, 3, 4, 1, 2, 3. And that is what that line is going to look like. Now, again, I have definitely had people that draw this whole line like this, and then they go back and erase that part that they don't need. If you want to do that, you can. I would encourage, if you do that, to draw lightly, so when you erase, it completely erases. And again, when I say the open circle and closed circle, on this one, it just so happened to be right there on that y-axis because of this 0 over here. X is equal to 0, x is smaller than 0. It's not always going to be like that. This one was at 3, where we have the open circle and the filled-in circle. So this is as complicated as it is, where we have 3 lines. Now, again, a lot of times, it's not like this every time, but I try to make each one of these lines really isn't too bad. You just have to remember, again, if it just says 5, that's a horizontal line at 5. Whereas it's 3, that's a horizontal line at -3. Again, I put those on there to help you, not to confuse you. My points are at 2 and -2. The reason it's called a piecewise function is because all these parts of the function go in these, or all these functions, you're just graphing a piece of those. So the first one, we graph if it's bigger than 2. So bigger than 2 is over here. That's going to be the 5. Between -2 and 2, that's going to be the middle here. And then if it is over here on the left. So this last one is on the left, the middle, and this top one is over here on the right. Now we graph those. So at 1, 2, 3, 4, 5, it's just a vertical line. Rather, sorry. Open circle, and again, it's just a 5, so it's just a horizontal line. This one is both. We start and stop is both filled in. And again, if you don't remember that, that's y is equal to x. Hopefully you have that memorized, but if not, it's slope intercept form. The y-intercept is 0. My slope is up 1 over 1. They're both filled in on each, where they start and stop, they're both solid because they both have equal. And the last one is everything to the left of that -2, and that is -3, so that is right here, and it is space here and open. A lot going on. Keep in mind, you know how to do these already. You just have to make sure your sections lead with or where each section needs to be. Go ahead, do number 4 on your own. And I'll give you about a minute or two, and then we'll look at that one. And again, the first one's in slope-intercept form. The second one is just a vertical line. And again, it's where x's are 0. So this one, just like number 2, it's going to be right on that y-axis. That's kind of nice. All right, so to go over this one real quick. Again, we have 5x plus 4. That's all when x is less than 0, so that's everything to the left. So the y-intercept is at 4. And we would normally go up 5 over 1. If you do that, that's fine. That's just over here. But remember, we're only graphing this line on the left of that line. So instead of up 5 over 1 to the right, I go down 5, 1, 2, 3, 4, 5, over 1 to the left. 1, 2, 3, 4, 5. Something like that. And then the other one, the 6, is everything greater than 0. So 6 is what? 1, 2, 3, 4, 5. 1, 2, 3, 4. Scared me. It is an open circle, and again, it's just a vertical line. And like I said, make sure you know those vertical lines. There will never be a vertical line because a vertical line is not a function. We don't need to get into the depth of that. But we only have horizontal lines. You will never have vertical lines. And again, I put them in there because they are no slope-intercept form. They're a lot quicker than that, especially with piecewise function. Any questions on that before we move on? This is definitely one that before you guys do the exit ticket, I would definitely make sure you get some practice with this on the worksheet because it does take a little bit sometimes for it to click. So I think this next part's a little bit easier. You're just evaluating the piecewise function. So the first one we have, number 5, we will not have any that actually look like this. We'll have ones more like number 6. But I want to start you out slow. Equation, I have to evaluate it. I only use that equation between -2 and 3. If my x is in between -2 and 3. When you look at this to evaluate, the first one, your x is -1. So what? -1 is in between -2 and 3, and so I will be able to plug in -1 for that. So that's 2 times -1 minus 1. -2, but that absolute value is to +2. So 2 times 2. So 1 worked fine, so I plug -1 in for that. That's 2. 2 in? Yeah, because 2 is also in between -2 and 3. Times 2 minus 1. That's 2 times the absolute value of 2 minus 1. That's 1. Again, the absolute value is just 2 times 1. That's that being 2. So again, we're just plugging numbers into an equation. We just have to make sure we're plugging it into the correct equation. Over this. It's not, but I took it off the test, and so I don't want to waste my time with it today. It's been crazy. You don't plug 5 in because 5 doesn't fit that one. It's not in between -2 and 3. It's bigger than 3. So we'd have to put 5 in somewhere else. So for right now, just put an X there. But normally speaking, on number 6, you'll be able to plug it in somewhere. Let's go on over to number 6, and let's see what this one looks like. So again, these are all equations. Y is equal to 4, y is equal to 2x, y is equal to 1/3 x minus 4, but we only use them if they follow this criteria. So first thing you have to do, g of 1 means my x is equal to 1. So where does 1 fit in here? 1 fits for this one. It's in between -2 and +2. So that's the equation we're using for that. So we have 2 times 1 is just 2. So g of 1 is 2. Move over to the next one. Our x is -5. So again, which one of these equations is the -5 going to fit into? Well, -5 is less than -2, so we're going to use this first equation, which is really nice because when you plug -5 in for that, there is no x to plug it in, so your answer is just 4. If it just has a number, no matter what number you plug in, your output's going to be 4. Your x is, your y is going to be 4. Then same thing, if your x is 9, which one's this going to fall into? It's going to fall into this one, where your x is bigger than 4, because 9 is bigger than 4. So that's when I plug it in that last equation. So 1/3 times 9 minus 4. 1/3 times 9 is 3. 3 minus 4 is -1. So g of 9 is -1. And the last one, g of 3. So again, I don't think I'm going to do this on a test or a quiz because I don't know exactly what you'd write in for this. Let's do NA because g of 3 does not fit anywhere. It's not smaller than -2. It's not in between -2 and 2, and it's not bigger than 4. So I'm just going to put NA for that one. I'm not going to put anything on a test or a quiz like that. I will say be careful, and I need to add 2 to those, but be careful if it says g of 2 or g of -2 rather, because that's when you really have to pay attention. Does -2 fall into this formula or to this equation? Which equation does -2 belong with? If you have g of -2, I'm going to write it in there. If you have g of -2, you have to use the second equation because that's where it has the equal to part. Everything less than -2 goes with that first equation, but everything less than or equal to or greater than or equal to -2 goes with that second one. So that would be -4. So again, just be careful with that equal to part. That usually shows up. I mean, again, that's one of those things that shows up on the test once, sometimes. Usually once or twice. Now, this is what I think is a lot easier. So we're doing the same thing where we are evaluating, but now they give us the graph. So it's the same thing we did earlier with the graph. Remember, you found where your x was, your 2, and then you went up or down until you hit different parts of the graph, but that's fine. So f of 2, up until you hit right here would be a 3. 2 is just 3. 1, we'll get -1. Where do you go? Is it this function or is it this function? And that's where it comes into play if it's an open circle or if it's filled in. So you kind of think of -1 goes through the open circle. It doesn't stop there. It hits this one where it's a closed in circle. So that one is also at 3. F of 6, so all the way up here, that's -2. F of -4 goes up to +4. And F of +4 right here, if you go up or down, you don't hit your graph at all. And so again, I'm just going to put NA. I don't actually know what the best terminology is for that one. I guess maybe a no solution or an empty set wouldn't be a bad idea. That's probably what it is. It's probably what I should do. And F of 0, again, you go up or down so you hit your function. You go up to 3. So I think, all things considered, I think that's probably the easiest done today. Again, you just have that visual where you go up or down until you hit that graph. It's the same thing we just, except for now we have the graph instead of the equations. Before I move on, we'll take a little second. Are there any questions? And I just want it, I mean, not like giving things time to literally soak in, but just kind of take a breath. Because again, I know it's one of those things that it's almost a weird mix because, I mean, first off, some people look at this and think it's easy. Some people don't ever understand it. but also it's one of those things that's almost hard because you kind of understand part of it because it's the same slope-intercept form we've always done. It's the same evaluating we've always done or that we've done this chapter. It just looks a little bit different knowing where to plug things in and where things go. Okay. Sorry. It's pondering the test. This test is one of those that we have 7 sections, and so I would love to give you stuff over everything, but I just can't. There's stuff I have to skip over. So I was trying to figure out what I should put on there. Number 8 is doing the opposite, where you are writing the equation of that. Again, I don't know whether this is easier or harder. I almost think it's maybe easier because you can see the graph, maybe because I just don't really like graphing. But the way I always do this, from left to right. So I still hook that dotted line. This is where it goes from one equation to another. Number 9 has 2 different dotted lines because it has 2 different ending and stopping points. I make sure I realize that's at 2. And my first equation, again, I just go from left to right, so I'm going to do this equation first. And I just write it down in slope-intercept form. You just don't write the y is equal to because that's what this is. That part, I'm not going to capture. I'm not going to be finding it. So your slope is -1 because you go down 1 to the right. So -1x. Your y-intercept is 0. If you put plus 0, that's fine. But that's the equation for that first one. But you have to specify that you only do that equation if your x is less than 2. Last but not least, it's only less than 2 because it's an open interval. You don't put the equal to sign with it. Now, in between here, and I've tried to throw everything at you, but they use the word if sometimes, they use the word when, sometimes they use a comma or a semicolon. I don't care. Just make sure you leave a little bit of space. But again, a lot of people say if or it's -x when this happens. Part of my equation then, and again, this sort of hard because a lot of people say, well, the y-intercept is right here at 3. Well, the y-intercept isn't here at 3 because the y-intercept is over here. So what does the y-intercept be? You just have to a little bit. Your y-intercept would be. You can put a little dot there too. The slope is up 1 over 2. Up 1 over 2x. And plus 2 will be your y-intercept. And again, this is for everything that is bigger than 2. And you've got the equal to sign with it because it's solid in there. What I'm doing is I put those 2 equations and I specify. One of them is where x's are less than 2. Everything left. One of them is where x's are bigger than 2, so everything to the right of 2. Unless it's extra credit, I'm not going to give you one of those that has 3 different functions to put down. I mean, technically, as many as you want. I'm not going to do that to you guys. Same thing with this next one. Just make sure you're careful. Zoom in maybe a little bit. I put these steps over here. I should have read these. But really, again, it's kind of the same as it is what I said. I just didn't read them specifically. Find your slope, find your y-intercept, or what your y-intercept would be. That's a key. And then look at that inequality for your starting point. Okay. Is at 1. So everything to the left of 1. So this, and you could start with this. That's where everything is less than 1 or equal to because it's solid. So if that helps, if you want to start with that part, you totally can. Then slope-intercept form, my y-intercept is at -3. My slope is up 1, 2, 3 over 1. So my slope is 3. So 3x minus 3 is that equation. And again, that's only if x is less than or equal to 1. Now the next one is if x is greater than or equal to, but now it's +3. There's a little gap in there, so just be aware of that. A lot of times they'll be the same number. X is less than 1, x is bigger than 1, kind of like the last one we did. but this one there's a little bit of a gap. Now again, this one's really nice because it's just a horizontal line. If it's a horizontal line, you just put the number, no X's, so that's just 4. And that's why I was saying those horizontal lines need to be your best friends. I'm going to put those on the test for sure because they should be easier, they should be quicker. Part is the same thing we've done. We're putting in kind of a different rotation. We're just doing pieces of those. Okay. Last but not least, we're going to talk about the domain and range of these. So, we'll not have ones like this on the test. These are ones that are not two-dimensional. These are just one-dimensional. But I thought I'd start on this before. I'm going to give you a new notation for this because I think the new notation, I thought about scrapping it because I don't want to teach you anything new if I don't have to. Here, so the old notation is where we do x is less than or equal to -3, or -1 is less than or equal to x is less than 2, so on and so forth. Instead, there's a notation where you your lowest number and the next number to come to where it stops, and you use either a bracket or a parenthesis depending on if that dot is filled in. We goes to the left, so we start at -infinity. Arrow goes to the left, forever never starts at -infinity. Anytime you have an infinity, you have a parenthesis. Parenthesis is not equal to. It can never actually be equal to infinity, so you always do a parenthesis for infinity. So it starts at -infinity, and then it goes all the way up to -3 before it takes a break here. So it goes to -3, and it's filled in, so I put a bracket for that one. So again, that represents, it picks up at -1, and it is filled in. You're going to leave a little bit of space. I'll show you what goes in there in a second. Starts at -1, bracket, because it's filled in. A +2, and then it's a parenthesis. It's not filled in. Leave a little bit of space. And then the last one is 3. It's an open circle, and it goes to +infinity, which is also a parenthesis, an open circle. The only other thing you have to do is you should put these, they're U's. I've heard people say they stand for union. I don't actually know if that's what they stand for, if that's what they tell you to remember it by. Greek letters, and it just so happens to be fitting. If you honestly put those U's, that doesn't bother me at all. But I think that's the inequalities. And honestly, on the other problems that we've done where we talk about the domain and range, if you'd rather do it this way, that's fine too. I don't care which way you do it. I just wanted to introduce this because, I mean, it is nice to expose you to another method. But also with this specific thing, I think it's a lot easier. So same thing with this next one. We start at -infinity, so it's a parenthesis. It goes from -infinity to -1, and then it's a bracket because it's filled in. And then we have an open one at 0, but it goes to 2, and then there's another bracket. And then the last one is at 4. It's a parenthesis, and it stops at +infinity, which is another parenthesis. It goes on forever. So now we're going to use that. Again, we won't have any questions like that on our test exactly, but we might have questions like 12, 13, and 14. So now we're going to use that method. We're going to use that theory or that notation to go over these other graphs. Really, when we talk about the domain and range, remember we talk about where is the function on your x's, where is the function for your y's. Now, one thing I've told students that helps you, you think of taking, at least for the domain, or 2 pieces of wood and stashing it straight on this line. And your range, you do the same thing on the line out. Switching it. So if we did that, or if you can imagine, this line, if we squish it on the x-axis, would start here, it's filled in, and it would go this way. Push this part down, circle here, and then it go all to the right. Now you do it the same way as what we just did. So this one, the domain, goes from negative 2, bracket, goes from positive 1 to positive infinity. Same thing with the range. We take this whole thing and we squish it in here. Well, one thing I'll say, this first one, when we take this line, I always imagine it's like you set it and then you just really stomp on it how hard you can. So it goes from a normal size can to then this one that's it's not any wider. It just looks like a little round circle. That's this. I took this whole line, I squished it down so this ends up being 1 point. I will tell you one thing, people get the circle, but when I squish it down, all these other points squish in and fill in the circle. So that is 1 point right here. 2. This other one, I push this all against that axis, so it kind of starts here, and it kind of goes up and then comes down again, so it really just looks like a line that comes down. That's my range. In my range, you always start from the bottom. That's at negative infinity, and it goes up to positive 2, and that's it. It doesn't go to positive infinity. It goes up to 2, and there's nothing above that. This way for your other problems that we did earlier, you're more than welcome to. Let me try to wrap this up quick because your quizzes or your same thing on this other one. If I press that 13 straight down, it would look like this. If I push the other one straight up, it would be open here and then filled in over here. But again, this one is open. Filled in because there was already a point there. So from negative infinity to positive 4. Domain. And your range, same thing, this would squish down to 1 single point. This would squish up. So it would start at negative 2. So I have negative 2 all by itself in a bracket, because there's just a dot. And then it would start at 0 and go to positive infinity. And last but not least, this one, if you squish this down on the x-axis, those are both open, so they never fill themselves in. So that's still an open circle here. I apologize, this graph doesn't look super great. But it's everything else besides that one. I'm sure there's a better way to represent this, but to stay consistent, it goes from negative infinity to positive 4. And then it goes from positive 4 to positive infinity. I just don't have a bracket at 4 at all. And then this other one, this one is open and goes all the way up. This one's open here, but it's filled in. There's already a point there and goes all the way down. So your range goes from negative infinity to positive infinity. If you want to put all real numbers there, you can. That also is fine. Now, before we put stuff away, I will tell you, this is one of those lessons that's hard for me because I know some of you guys, your head is spinning. There's just a lot that's going on right now. But others of you guys went through this and didn't think it was really that bad. So my biggest recommendation is you need to make sure you're doing your worksheet. It appears, at least with those quizzes, that some people aren't getting that extra exercise. And it's starting to show on, well, it did on the last quiz. So, especially if your head is spinning, do the worksheet, watch the video. When you get to a problem on your worksheet, watch the examples on the video, try to work that out. Ask questions if you need to. I apologize that that's kind of a lot in one lesson. But again, it would have been one of those, if we would have split it up, it would have been 2 really short days, and we would have ended up with 8 lessons in this chapter. I'm going to try to run over and get your practice test